So 4.2 part 1 is all about the unit circle. We're going to be using the unit circle to evaluate trig functions. So as the real number line is wrapped around the circle, each real number t corresponds to a point. So just remember that all of our angles that we're looking at come from the origin, and they all make a right triangle. So we have our right triangle here. We have our x, which is on the x-axis, our y is on the y-axis, and all of our trig functions are going to involve SOHCAHTOA. So you guys remember that from geometry? This is just a little deeper into SOHCAHTOA. So we have sine, cosine, and tangent. Sine goes along with cosecant, they're reciprocals of each other. Cosine goes with secant, and tangent goes with cotangent. So along with sine, cosine, and tangent, we're introducing 3 more trig functions: cosecant, secant, and cotangent. And sine and cosecant are reciprocals of each other. Cosine and secant are reciprocals, and tangent and cotangent are reciprocals. And we'll go over on the next slide how exactly they are reciprocals of each other. One last thing to point out here is that we abbreviate them as sine, cosine, tangent, cosecant, secant, and cotangent. It's not sin, it's sine. We would abbreviate them this way, but we say them this way. Okay. So if we have our right triangle here, we said this was y, this is x, and this is our angle that we're looking at here. Sine, we know is so opposite over hypotenuse. Our opposite would be y, and our hypotenuse is 1. So the sine of t would be y over 1, or just y. Cosecant is the reciprocal, so we would just flip it. It would be 1 over y. Cosine would be co, so that is adjacent over hypotenuse, so that would be x over 1, or just x. And then secant is the reciprocal of that, so we would flip it to 1 over x. And then tan is TOA. So opposite over adjacent, y over x, and cotangent would be the reciprocal of that, x over y. So typically, you guys would have to memorize these trig functions. But now that you get to use your notes on the test and quiz, make sure you have this with you, because this is important. This is what you need to solve everything from 4.2. This little box. And then we have some handy dandy tips down here on how to evaluate. Ms. Meadows was kind enough to include this on the notes. So our steps to evaluate: first thing we need to do is find the radian or degree measure that corresponds with the question. So our question will give us a radian or degree. We are going to use our unit circle, which we have on the next slide, to find an x and y point that coordinate with that. We use the chart to evaluate the x and y values given the radian or degree measure, and then we always have to rationalize the denominator, no square roots in the denominator. WebAssign will let you have like 1 over square root of 3. This is okay in WebAssign, but it's not okay on a quiz or test. So just keep that in mind. WebAssign will let you put this in as a right answer, but you will have to rationalize on a quiz or test. So how would we rationalize 1 over square root 3? What do we need to do to get that square root out of the denominator?
You have to multiply it by square root of 3.
Multiply the top and the bottom by square root 3. Perfect. So we would get square root 3 on the top, and then what's square root 3 times square root 3? 3. So this is equal to this. But again, on WebAssign, you can just leave it as the square root in the denominator. Okay, this brings us to our examples. So we have to evaluate the 6 trig functions at each real number. So for A, it gives us t is equal to pi over 6. First thing we need to do is find the point that corresponds to pi over 6 on our unit circle. So typically in the past, this would be something that you would have to memorize, but you're going to have it in front of you for your test and your quiz. So super helpful that you guys have this here. So this is our unit circle. You need it to evaluate all of these. So first thing we need to do is find pi over 6 on our unit circle, and we find the x and y point that coordinates with that. So we have the square root 3 over 2 and 1/2. So this would be square root 3 over 2, comma, 1/2. So we have our x and our y. Now we need to take all 6 trig functions and just plug in our x and our y. So first we have sine of pi over 6. What is our formula for sine? So going back to the chart on the last page. What's sine of t equal to? Y. So what's our y? 1/2. So sine of pi over 6 is 1/2. Next, we have cosine. What's our formula for cosine? Cosine of t is equal to x. So what's our x? Square root 3 over 2. Next, we have tangent. What's tangent of t? What's our formula for tan t? Y over x. So we need to take our y, which is 1/2, over our x, which is square root 3 over 2. How can we simplify this?
Multiply by 2.
We can, so we keep the top, change its multiplication, and flip the bottom. So we're multiplying it by 2 over square root 3. Keep, change, flip. Now we multiply our fractions, we just multiply the numerators together and then the denominators. So 2 times 1 would be 2. 2 times square root 3 is 2 square root 3. Can we simplify this? Yep, the 2's cancel out. And then we need to rationalize this. So what do we need to do to it? Multiply the top and bottom by square root 3. So this would give us square root 3 over 3. So the tan of pi over 6 is equal to square root 3 over 3. Okay, now we have our cosecant. What's our formula for cosecant?
1 over y.
1 over y. So we have 1 over 1/2. We can do the same thing. We keep change flip. So this would be 1 times 2 over 1, which would just be 2. Another way you could do the cosecant is we see that the sine is 1/2, we just flip it. So it would be 2 over 1. Okay, next we have the secant. So what's our formula for secant t?
One over x.
1 over x. So we would have 1 over our x, which is square root 3 over 2. Or we could just take our cosine and flip it. So this would be 2 over square root 3.
Would we have to get rid of the square root though, right?
Yep. So we multiply the top and the bottom by square root 3. So we have 2 square root 3 over 3. Okay, so if we actually had 1 over square root 3 over 2, we do the same thing we did before. Keep the numerator, change it to multiplication, flip the denominator. So 1 times 2 over square root 3, which would just be 2 over square root 3. So this is the same
But we
thing.
can still do what you did, right? At the
Yeah.
beginning?
Yeah, you can always just flip the sine or flip the cosine, and that would give you the cosecant and the secant. So that will always work. Okay, lastly we have the cotangent. What's our formula for cotangent t? X over y. So our x is square root 3 over 2. Our y is 1/2. Keep the numerator, change to multiplication, flip the denominator. So what is square root 3 times 2 would be 2 square root 3 over 2. How do we simplify this? So what are we left with? Just square root 3. So these are our 6 trig functions.
Scarlett,
Yes.
why couldn't you just flip your answer from the tangent one?
We could have, because we saw that before we rationalized our tangent, we had this 1 over square root 3, and we could just flip it. So we definitely could have done that. All this work for one question. It's technically like 6 questions in one. But yes, all this work for one question. Okay, I'm going to rewrite b down below. So for b, we have t is equal to 5 pi over 4. What's the first thing we need to do to start?
Look on the, look on your right.
Look at the unit circle. So we have 5 pi over 4, which would be down here.
Yeah.
So our x is negative square root 2 over 2, and our y is negative square root 2 over 2. This is our x, and this is our y. It always helps to label it just so you know what's going where. I find it easier just to label it. It's one extra step, but it's kind of a quick step. So first thing we need to do is find sine of 5 pi over 4. What's sine? Y. So it would just be negative square root 2 over 2. What's cosine?
X.
x, so it would be negative square root 2 over 2. What's tangent?
Y over x.
Y over x, so this would be negative square root 2 over 2 over negative square root 2 over 2. So we keep the numerator, change the multiplication, flip the denominator. So we multiply, we get negative 2 square root 2 over negative 2 square root 2. What happens here? It's just 1.
Yeah.
Okay, now we have our cosecant. What's our cosecant?
One over y.
1 over y, so we have 1 over negative square root 2 over 2. Keep change, flip. So this would be negative 2 over square root 2. What do we need to do? Rationalize, so we multiply the top and the bottom by square root 2. So we get negative 2 square root 2 over 2. How can we simplify this?
Just be square root 2, right?
Negative square root 2.
Negative square root 2. Yeah.
I'm going to rewrite it down here. Okay, next we have the secant. So we know that secant is 1 over x. We also know it's the reciprocal of cosine, so we can just flip this. So it would be negative 2 over square root 2. Then we have to rationalize, so we multiply the top and the bottom by square root 2. Negative 2 square root 2 over 2. 2's cancel out. Negative square root 2. Okay, lastly, we have cotangent. Cotangent would be x over y. So we could put negative square root 2 over 2 over negative 2, negative square root 2 over 2, or we can just take the tangent and flip it. So what's the reciprocal of 1? 1.
1.
So our cotangent is just 1. So we have our sine, cosine, tangent, cosecant, secant, and cotangent. So these are not super difficult. They're just, like I said, 6 problems in one. So it's, yeah. So for cotangent, you just take the reciprocal of tangent. So like on the third slide, how I mentioned that sine was the reciprocal of cosecant, cosine's the reciprocal of secant, and tangent's the reciprocal of cotangent. You can flip the second 3 functions to give you can flip the first 3 functions to give you the second 3. Okay, that was B. Any questions on A or B? Any questions so far?
Nope.
All right, let's go to C. So T is equal to pi. What's the first thing we need to do?
Look at the unit circle.
Look at the unit circle. So pi -1, 0. So first thing is sine. What's the formula for sine?
Equals -1, it's just x. I mean 0 because y.
Right, sine is with y, so it would just be 0. If you put sine of pi in your calculator, if you're in radians, and you put sine of pi in the calculator, you will get 0. All of these problems you can do in the calculator. They all work. But you guys have to use the unit circle for them because we asked for exact answers, so the calculator wouldn't give you square root 3 over 2. It would give you the decimal of that. So that's why you have to do it this way. And I don't know if you'll be able to use your calculator for the next quiz, but I'll let you guys know. Okay, next we have cosine. What's cosine of pi?
It's just x, so -1.
-1. Then we have tangent. What's tangent of pi?
And then it's 0 over -1.
0 over -1, which is?
Undefined.
What if we have 0 on the top?
Oh wait, no. It's just 0, yeah.
0.
Yeah, yeah.
Okay, next we have cosecant. So cosecant of pi would be 1 over y. So 1 over 0.
Then undefined.
Then it's undefined.
Yeah.
Next we have secant. Secant would be 1 over x, or we could just flip cosine. So what would secant of pi be?
Should be -1.
-1. And then tangent of pi, or cotangent, my bad. Cotangent pi.
And it'd be -1 over 0.
And what happens to -1 over 0?
Undefined.
Undefined. So these
That
are,
was easy. Fast.
they're all easy.
Yeah. The other ones is just more steps when like different numbers, so like the square root.
Yeah. It's more steps when you have to rationalize it. But yeah,
Yeah.
this one is easy. Alright, last one, D. What's the first thing we need to do for D? Find it on the unit circle. So we need to find negative pi over 3. So negative pi over 3, we're going in the negative direction. So I find it easier to think of this as in degrees. So what would pi over 3 be in degrees? 60 degrees. So now we're looking at negative 60 degrees because it's negative. So on our unit circle, we start at 0 and go in the negative direction. So what would be the positive version of negative 60 degrees? (300 degrees). So we're looking at 300 degrees, which is 5 pi over 3. So here we can say negative pi over 3 or 5 pi over 3. So what's our x and y? One half is our x, and our y is negative square root 3 over 2. So first thing we need to do is find our sine. Sine is what? Y. So negative square root 3 over 2. Cosine is what? X, so 1/2. Tangent, y over x. So this would be negative square root 3 over 2 over 1/2. Keep, change, flip. The 2's cancel out, so we would get negative square root 3 over 1, which would just be negative square root 3. All right, next we have cosecant. What's our cosecant? One over y, or we can just flip the sign. So we have negative square root 3 over 2. This would become negative 2 over square root 3. What do we have to do next? Rationalize. So we
have to get rid of the square root.
Yep, we get rid of the square root. So this would be negative 2 square root 3 over 3. So again, on WebAssign, you could just leave your answer like this. You can leave it with the square root on the bottom for WebAssign. But on the quiz, you have to rationalize. Okay, next we have secant. What would our secant be?
Just the reciprocal of sine. So it's 2 over negative square root 3.
Secant is the reciprocal of cosine.
Oh, yeah.
Oh yeah, cosine. So it's 2 over 1.
So just 2. No. We are looking at the signs from here, from what it gave us. So since 1/2 is positive and we flip that, it would just be positive 2. So it's not like the opposite reciprocal, it's just the reciprocal. We only flip it. Next we have cotangent. So what would our cotangent be?
Negative square root of 3 over 1.
Negative
Or is it 1 over?
1 over negative square root 3. Because this would be negative square root 3 over 1, and then we need to flip the tangent.
Yeah.
So then
Wait,
we...
Miss Cooper?
Yes.
Wait, you can finish this one. That answer's done, right? Or we have to rationalize it first, right?
We have to rationalize it.
Yeah. Over 3.
So negative square root 3 over 3.
Yeah. Wait, but for going back, how'd you go from the negative 60 to 300 again?
Okay, I'll go back and explain that.
Just from like that degrees form.
So you agree that negative pi over 3 is the same as negative 60?
Yeah, it's a degree, yeah.
I just changed it to degrees so we could see it a little bit better. Remember, for negative degrees, we're going from 0 down this way.
Mm-hmm.
So if we're going negative 60 degrees, we go down 60 degrees this way. So then
and
down
the third
60
one.
would be
Okay.
300. Because we start at 360 and we're going down 60.
Okay. All right, thank you.
You're
Yeah.
welcome.